Hello, and welcome to an episode of TI84 Calculated Programs. Today we're going to work the mechanics solver on gravitational programs. Okay, enough of the jaw jacking. I am stoked today. Two major themes. One is some of these answers are going to be like really close, so we got approximations, so it's going to be good enough for government work. Oh yeah. The second one is these questions are set up just as diabolically as they'd be set up by your physics instructor, professor, teacher. You know, I know I've said, oh, no offense to physics teachers, instructors, whatever. But dude, no, to heck with these people, because this is how mean it's going to be on your test, quiz, or your final. So I'll guide you through it. Without further ado, we're going to go over this. We've got these major equations here. F equals g m1 m2 over r squared. That's like a universal gravitational thing. G equals g m over r squared, gravitational field strength. U equals negative gm over r, gravitational potential energy. Then we got orbital motion, escape velocity. So look, if I get the signs wrong, like negative versus positive, flame me in the comments. I like engagement, even if you're a bot. Okay, so here I see, without further ado. Okay, first one. A satellite orbits Earth, mass is 5.97 times 10 to the fourth kg, altitude of 400 kilometers above the surface. Calculate its orbital velocity. So when it says orbital stuff, I'm just going to assume it's equation 4 here, orbital motion. And then what we're trying to find, its velocity. So I'm assuming that's v. It's going to be that equation there. So g is going to be that 6.674 times 10 to the negative 11th Newton meters squared per kilogram squared. Okay, here's the deal. G is already in the calculator. It's in there. It's in there. So you don't have to like post it because it's a universal gravitational constant, I believe. M, well, it's not the mass of the satellite. It's the mass of whatever it's orbiting, just so you know, because I didn't know that for a long time. And I was like, why am I getting these problems wrong? So it's 5.97 times 10 to the 24th. So that's what's kind of cool, you know, because the teacher could give the satellite mass, which probably teacher would. It's a red herring. You don't need to know that. It's the mass of the Earth that counts. And then the radius. Now this is what's so diabolical, right? It's whatever the Earth's radius is plus that 400 kilometers, okay? And again, this is like all the hallmarks of a nasty physics problem. And what I mean by that is, dude, you got to give it in meters. This is kilometers. So that's 400,000 meters, right? Or 4 times 10 to the 6, right? But that's not actually what you enter because it's going to be the Earth's radius plus that altitude. So I'm assuming the Earth's radius is something like 2.77 times 10 to the 6 meters. Okay, just, I know I'm getting a little too enthusiastic about this. You know, I identify as a nerd, I guess. But I just want to show you because this is kind of what steered me away from physics, not knowing all these like little details. But here we go. Velocity 7671. Now see, this is an approximation thing. It looks like an equal sign that's trying to dance. 7670, that's cool, in meters per second. Again, you guys are gonna have to memorize your units. I don't have it on this version of the physics program. Okay, on to number 2. We go on. Okay, calculate the gravitational force between Earth and the Moon. The equation F equals g m1 m2 over r squared. R, by the way, I know you're thinking it's a radius, but it's also a distance. So if we have like an object here, we have an object here, this gray distance between them, you could call that an R. Most regular human beings would call that a D. And I'm not trying to make a joke here. But yeah, radius and distance are basically interchangeable in physics. If you're a physics like purist, flame in the comments, get angry. Just talk to me like you condescend to somebody, mixing up mass and weight. Yeah, just do that. Just maybe you can exercise your demons that way. Okay, I know I'm just capping on physics people right now. I'm a reformed physics person. Okay, enough of me jaw jacking. We're gonna do F equals g m1 m2 over r squared. This first equation. We're gonna solve for the F here. M1, what's the mass of the Earth? Man, and this is what's crazy, because like back in my day, they'd be like, what is the mass of the Earth? They're like, look it up in the almanac. It's 5.97 times 10 to the 24th kgs. Yeah. I didn't know that. I mean, dude, now you can probably like look it up real easily on the internet. But I'm hoping that the information I have here is right. If it isn't, well, you know, we're all going to get this wrong. Okay. And then the radius, again, put it in meters, 3.84 times 10 to the 8th. If, you know, hey man, you like going old school, just don't use scientific notation. That's cool. Just put a bunch of zeros in. Okay, so we got 1.98 times 10 to the 20th. That's what E, whoa, I didn't know you could do that. E to the 20th, that's what it means, times 10 to the 20th, just so you know. So it's 1.98 times 10 to the 20 newtons. Again, units, just be aware of that. I'm not like a big units guy. I'm not great with the units. So that's why I'm putting the burden on you to memorize units. Okay, enough of jaw jacking. Go to the next problem, number 3. What's the orbital period of Mars around the sun? I'm going to assume that's orbital motion. That's what I labeled like that. And then, okay, yeah, period, T. So it's kind of like a throwback to math class where T is period. I know you're like, why isn't it P? I'm like, I don't know, probably the Germans got to it first. And I know, again, the linguists are like, well, English is a Germanic language. I know that. I speak ein bisschen Deutsch. But T is period. I don't know, I'm going off on tangents today. Maybe I'm just off my meds. Mass of the sun, like I'm supposed to know that. I hope that is a given. 1.989 times 10. And then just raised to that's the caret symbol. Not for real, that is a caret symbol. C-A-R-E-T, I think. I'm not exactly sure. I think that's what it is. Radius, that's the distance from the sun. 2.28 times 10 raised to the 11th. Okay, good. And then T is approximately, okay. When I talk about devious physics stuff, right? You're going to write this in seconds, and your professor, your teacher, instructor, whatever, teacher's assistant or whatever. How many days is it? So, dude, you've got to do this. You got to do 5.93 times 10 to the 7th seconds, and you got to do all this unitary conversion. Like, how many seconds, blah, blah, blah. So, like, 3,600 seconds in an hour. And I know because somebody's going to be like, I know the conversion. There's like, I don't know, so many seconds in a day. I don't know, man. Like one day, 24 hours. Oh my gosh. What is, I'm just going to on my other calculator. I have so many TI84 calculators. You have no idea. Yeah, it's 86,400 seconds in a day. So you got to do that and blah, blah, blah. You get 687 days. So look, be aware. Your teacher may say, I want the answer in days, and then I'm giving you the answer in seconds. So you've been warned. I have this video up. It's going to be dated, so you can't come crying to me that the answer's in seconds. Okay. In any case, find the escape velocity from Jupiter's moon Europa. Okay, good. Escape velocity. See, I didn't put the equation here for 4 and 5. I didn't even know what the equations are. I got to look at them. But I wrote escape vel, orbital motion. Look, for number 2, grav field strength. I put gravity field strength, or gravitational field strength. Gravitational potential energy for the U thing, okay? To help make it user-friendly. Something that usually math and science are not. Okay. VE, V sub E. I know, you're like, why didn't you write a sub E? Dude, I can't in TI84. Well, maybe you can. I don't know how. Okay. What is the mass of Europa, if you're speaking German? Speaking of that. 4.8 times 10 raised to the what? The 22nd. Okay, good. And then we got R, the distance, 1.56. I know, you're thinking radius. You're like, where's the circle? 10 to the 6. Oh, man, I hope I get this right. Okay, approximately 2025. We're going to go with approximately, 2026. That's cool, close enough for government work. Here we go. It's just an expression. Don't get offended. I've got relatives who work for the government. Okay, problem 5. Calculate the gravitational potential energy per kilogram of a satellite at geostationary orbit. U equals negative gm over r. If your teacher didn't give you this, oops, whoa, okay, didn't give you that, for example, U, gravitational potential energy. Okay, cool, I've got it labeled. Isn't that wonderful? Yes, it is. Okay, so we're going to do option 3. And then we're going to solve the gravitational potential energy, solve for U. R, I'm sure, is the distance. So what is the mass of the Earth? That's 5.97 times 10 raised to the 24. Okay. And then the R, the radius, the distance, 4.22 times 10 raised to the 7th. There we go. and they get negative. Okay, it's joules per kilogram, so I don't know how this works out, but you know, it's approximately, you said, I remember I said, you know, the theme, one of the themes today is going to be approximate. So we're going to say we're right. Okay. Not to be arrogant, but I'm just saying it's close enough, right? Okay. Solve for the mass of the planet given its surface, gravity, and radius. So here's the thing. We're going to do m equals gr squared over g. And that looks like gravitational field strength here. So we're going to solve for the mass, which is a big ol' m, not the little m. Little g, 3.7 meters per second squared. So that's the acceleration due to gravity on that specific planet, even though I know on Earth it's like 9.8, 9.81. I know you guys are like, well, it's 9, it's 10 in AP physics. Dude, I don't know when that happened. Not when I was in high school. 3.39 times 10 to the 6 for this radius. Okay, we got it. And then m, again, we're saying it's approximate. So I'm going to say 6.37. The real answer might be 6.39 times 10 to the 23rd. We got the e23rd, so that's 10 to the 23rd. Maybe Mars is on a diet, you know? Maybe it's keto, paleo. Okay, so we're going to say that's cool. Calculate the gravitational field strength. Ooh, gravitational field strength, that's option 2. At an altitude of 1,000 kilometers above Earth's surface. So look, the equation is this, the G equals big old G, you know, that universal gravitational constant, m over r squared. So the mass of the Earth, right, we're going to, what are we solving for? Gravitational field strength, so it's going to be the little g. And then the m, it's the mass of the Earth, 5.97, like I know this, times 10 raised to the 24th. Okay, there we go. And then r, what's the radius? Now here it is. It's 1,000 kilometers above Earth's surface. What does that mean? It's 1,000,000 meters, right? So we got to calculate what all this stuff is. 7.37 times 10 to the 6. So you got to know what the radius of the Earth is itself, and then add that extra 1,000,000 meters, or 1 times 10 to the, what is that, 6 meters? Okay, so 7.37. I'm not trying to confuse you, honestly. I am trying to help. Times 10 raised to the 6. So I want to call that 7.34, so we're going to call that one correct. Okay, we continue. Number 8, 8 of 9. We're so close. The penultimate question. Find the radius of a planet's orbit given its orbital period around the sun. Good. Orbital motion, baby. Labeled it for you really well. Thank you. You can thank me in the comments. You can thank me if you like this video. If you don't like it, tell me why. You got to say specifically why. You don't like my accent. You don't like the way I speak. I don't know, you don't like mistakes I make, that's okay. That's totally legit. But then if you say, hey man, could you add this or add that? Guess what? I do that. This is already the 5th rendition of this physics solver program. This thing's only been out like 2 months. So, and you get emailed updates of it as soon as I, double, triple check them and everything. Okay, without further ado, we go on to equation 3. What is the mass? The mass of the sun, 1.989 times 10 to the 30th, like somebody's actually weighed it. Like, give me a break. Okay. T, what is the period? So that's period. T stands for period again. 7.6 times 10 raised to 7. Again, that unit is in seconds. And then we get R is 2.688. Yes, times 10 to the 11th. E to the 11th means times 10 to the 11th. Okay, good. We get that one right. Awesome. Okay. Now, question 9. Calculate the distance between 2 objects given their gravitational force and masses. So this big ol' F1, the first one, is gravitational force, by the way. But we're going to solve for R, option 3. And look how awesome this is. I know I'm a shill. I'm a corporate shill for MCS tutoring. It gives you the formula, dude, or the equation R equals rad G M1 M2 over F. I do like that, and that's why I included that. So I'm just going to toot my own horn there. 2 times 10 raised to the 30th for the mass of that first object. And then second object is 3 times 10 raised to the 27. And then the F is 3.5. And this is all given, by the way. Your teacher would have to give it, unless your teacher is just totally diabolical. Okay, 1031. And there we go. 1.0696 times 10 to the 13th meters. Yes, yes, we're done. Dude, this is so awesome. This is the day I'm done going over this physics solver program. At least this iteration of it. It's by the time this thing's published, it'll be Phys Solve 5. Again, it solves all manner of physics mechanics questions. You know, it's got kinematics, dynamics, work. And you know what? I'll just, whoa. I did not mean for that to happen. Let's just go back so you see the whole thing. It's kinematics, dynamics, work energy, momentum, rotational, gravitational. It's got submenus for each. And just like this, it solves usually for any missing variable. And then also gives you the actual numerical answer, but not the units. So you do just have to memorize the units. So that's cool. So look, like it if you like it, dislike it if you don't. Available at mcstutoring.com. Probably link in the comments or description, something like that. You know the drill. You guys are like Generation YouTube. I'm not. But hey, I hope it helps. And good luck. Again, it's MCS Tutoring. We also have an SAT program, which is awesome for the math section. Chemistry Solver, which is actually our best-selling one other than our SAT. And then I have an electricity and magnetism solver, which is very similar to this, which means I have to do a freaking marathon probably through the month of February using that one and the ChemSolve. But look, stay tuned, subscribe. I'll see you next time. And good luck in all of your math, science, and SAT endeavors.